Hello, hi. Once again, welcome back to the channel. Here, we are going to begin with a new series that is SAST. So, as a first video, we are starting like what exactly the SAST and why it matters, how the SAST works, like what is the technical workflow, and what the SAST, DAST, as well as SCA difference, and how and what the SAST detects and what are the some popular tools in the SAST and in the DevSecOps workflow how the SAST can be integrated and by showing a real world example how the SAST will help in figuring out the code bugs and it's just a kind of best practices and recap of the video. Okay, so without further ado, let's enter into the video and have a discussion around it. Let's start with SAST. Basically, SAST is a static application security testing. Okay, here the idea is shifting the security left. That means we try to find the vulnerabilities as early as possible before they are going to live. That is exactly the significance of shift security left. So now let us see what is SAST. Okay, let me, yeah, what exactly the SAST is. Basically, it is a automated code analysis that scans the source code. Okay, the source code is the input for this. Uh, what exactly it scans? It scans for security vulnerabilities. The important point is that it analyzes the code without running the application, and that is why exactly it called as a SAST. Like that means static. When the code is in static, at that time it runs on the scan, and SAST will helps to identify the flaws early in the development phase. That means shift left security will be achieved, a shift left approach basically, and it works across like multiple programming languages like Java, Python, C Sharp, JavaScript, and many more. Now let us see why does this particular thing matters. Okay, so why exactly it matters was firstly it is early detection. That means we can catch the bugs before we are going to a deployment, and uh, secondly it gives a developers the power, like empowerment we can say. Okay, so they can fix the issues directly at the source. Okay, so in the development phase itself we can say, and thirdly it helps with compliance ready, the standards like PCI DSS, HIPAA, HIPAA. So we can able to achieve these compliance. Okay, so those are the some pointers, and there are a few more pointers. We can also achieve the like cost saving also. That means fixing of bugs in development is like up to 100 times cheaper than fixing in your production. So that is the reason. And finally it provides a complete coverage by scanning 100% of your code base. Okay, so you can think of it like a spell checker for security. Okay, so security spell checker where it will highlights the mistakes before you are going to publish any document, let's say. Okay, so here in the SAST case it identify the vulnerabilities, okay, before you deploy the application into production. Okay, so that is the that is why exactly the SAST is required and matters. Okay, now let us see how SAST works. Okay, that means what is the technical flow behind the scenes, how exactly it works as a scanner. Okay, here are the high level 6 steps as a process we can say. So at step 1 it starts with the code integration where the SAST tool first imports your source code or even a compiled binaries also. That means basically it takes in the code you have written or developer provided, so it can start analyzing that code binaries. Okay, and then second step was parsing and AST. That means the tool converts that particular code into something called as abstract syntax tree. You can think of this as a structured map of your code. It breaks down the code like into a logical components, so the tool can understand it in a better way. That is the reason. And the next step a pattern matching will be done. That means once the code is mapped accordingly, the tool will searches for a known vulnerable patterns. For example, it might look for insecure functions or some unsafe API calls or some any bad coding practices that attackers use that to exploit. Okay, so that pattern matching will be done in the third step. And in the fourth step, uh, here the data flow analysis was done. The tool tracks how the data moves through the application. That means it checks whether the sensitive data like passwords or any credit card numbers could be leaking, or any exposing APIs or anything, and it flows from one part of the code to the another part. Okay, so whenever the data is like flowing, is there any things exposing, okay, any sensitive information like that. Okay, and the next step, which is step 5, it will detect vulnerabilities. In this particular stage, the tool flags the potential security issues and assigns a severity rating also, so you can know which problem are like critical or high, and which problem causes major and minor severity. Okay, and the final step, it is going to generate a report. The tool produces a detailed report. This includes the findings, severity levels, and most importantly the remediation guidelines also, so the clear steps developers can follow to fix that particular finding or vulnerability. Okay, this is how exactly the technical flow, how exactly in the backend the SAST works, like basically the scanners we can say. Okay, so moving further, where we will be discussing, yeah, SAST versus DAST versus SCA. What exactly makes the difference between SAST, DAST, SCA? SAST is a static application security testing, DAST is a dynamic application security testing, SCA is a software composition analysis. Now let's understand the difference between this. So these are the like major approaches of application security testing. Uh, the SAST works with your source code binaries. Okay, so here the input will be the the code level access will be the source code and the binaries, and it will run during the development phase itself. Okay, so before the app going to a live, it will runs, and since the app doesn't running, it is obviously called as a static, so that is why it came as SAST. Okay, and it will find the code level flaws and logic errors. And for example, you can see here hard-coded password. That is the example for the SAST, and that is all about like SAST. Now coming to the DAST, where DAST, which is obviously different than SAST, it doesn't need a access to the source code all. It's kind of a black box. Okay, and you run it on your running application. When the application is running, that means that is why it is called as a dynamic. When it was running, that means it was in a dynamic state. And this particular dashed scan finds the runtime issues and the configuration problems, and here is the example like authentication bypass. So this is the dashed. And coming to the SCA, basically SCA, which is software composition analysis we can say, which is primarily focuses on the third party dependencies. Okay, and libraries also. So you run it at a build time, deploy time, or else during the like any further stages also. Okay, like build, test, deploy, any stages. Okay, so it will basically checks for the whether the components are vulnerable or not. Okay, and if you see the app state, it is a static libraries only. Okay, we need the libraries only, not any running components or something like that. Okay, and it finds the vulnerable components, and here is the example log4 shell vulnerability. Okay, if it found in your library, then that will be highlighted in the SCS scan. Okay, now let's simplify this with a small analogy example. By that it will be clearly understood for if you're feeling something like more technical. Okay, so as a non-technical example, you can think like SAST is a recipe before you are going to start your cooking process. Okay, let's say if you wanted to cook a something food, there might be a recipe followed for that, right? So it is a recipe for that, what is the blueprint we can say. And dashed is testing the finished meal. That means when the application is running, right? So sorry, not testing, it is testing. Okay, not testing. Okay, here a non-technical example, this one. So you can see here like how exactly the particular dish tastes. Okay, and here in the SCA, it is like checking your ingredients before cooking. Okay, first this will come, later this will come, later this will come as a flow. Okay, and I think so you got this particular like non-technical example. And here is the best practice, like use all three together, like SAST, DAST, and SEA, where it will give you a comprehensive security coverage across the entire software development lifecycle. Obviously, before for the packages it will give, for the static code it will give, for the running application it will give. So by this, your entire software development lifecycle will be secured if you use all those three together. And moving further, where we will be discussing about what actually the SAST detects, and what are the some popular tools used in the industry wide to detect vulnerabilities for SAST. Okay, so here are the some like common vulnerabilities which is catched by the SAST scanners, which is OWASP top 10 we can say. And if you see any of the SAST scanners, like that might be open source or that might be enterprise, obviously they feed this particular OWASP top 10 vulnerabilities, and they will directly able to detect these common vulnerabilities. Okay, so first one was injection flaws, uh, like SQL injection, LDAP injection, or some OS command injection that will be highlighted in the SQL flaws. And then broken access controls. You can consider insecure direct object references. So that was the broken access controls. And cryptographic failures. That means using a weak algorithms or some hard-coded keys. So that will comes under the cryptographic failures. And then XSS. That means cross-site scripting. Both reflected and stored types, what exactly how exactly it was. Okay, and then security misconfigurations, things like leaving a debug mode, or else using a default credentials, so that will be highlighted in the security misconfiguration. And here are the some popular SAST tools. Okay, and let me scroll down a little. Yeah, here are the popular SAST tools, some open source as well as enterprise also there. SonarCube, it is a popular open source tool which supports multiple languages, and it can be integrated into like multiple CI/CD pipelines also. And SimGrip, which is lightweight, very fast, and it allows you customizable roles. And then bind it, which is primarily focused on security scanning in Python. Okay, and then spot bugs, which is mainly for Java bug detection. Okay, called language specific, these two. And coming to the enterprise side, there is a Checkmarx, which is enterprise grade with extensive language support. And then Fortify, which is known for deep analysis and compliance reporting, and it provides multiple solutions. Fortify, I think some other tools also provides a multiple solution, but Fortify, like enterprise versions, provides SAST, DAST, SCA, all mostly all it was covering. Okay, and that too it provides a on-prem solutions. Okay, and cloud Checkmarx provides on-prem as well as cloud. As of now, Fortify, I don't see like a cloud SaaS based model. Most of the clients, they look for on-prem, so that is the main reason they consider on-prem solution. And VeraCode, which is a cloud based and developer friendly SaaS environment. And Sneak Code, which provides a real-time scanning directly inside the IDE. So whether you are a beginner or some experiencing, let's say if you are looking for open source tool, you can uh, start with these tools. Like if it is open source, you can start with this. If you are looking for your enterprise, you can start with this. And you can look for their like respective services which may fit into your requirements. And then moving to the next slide, where we will be discussing about SAST and DevSecOps workflow. Okay, so where exactly the SAST fits into a DevSecOps workflow. There are multiple areas we can say. First one was IDE plugins, where you can install a plugin that gives you real-time feedback while coding itself. Okay, and then the second placeholder was pre-commit hooks. It scans, it runs a scan before code uh, even going into a repository itself. And then in the third placeholder, we can say CI/CD pipeline, where automated scans happen on every build, each and every build. And the next placeholder was build gets. That means you can block the deployments if any critical vulnerabilities or issues were found during the SAST scan. And then security dashboard. So it will helps to track the metrics and trends over the time. Okay, we cannot say like it is a placeholder, but these are the like primary placeholders for, or the primary placeholders. And by using this centralized dashboard, it will helps to track vulnerabilities on priority. And let's say if multiple applications are there, multiple tools are, I mean teams are working, so to track as a centralized, it is very much helpful. Okay, and moving further, where we will be discussing about one of the real world example. Okay, like SQL injection. Now I mean, this was one of the practical example, one of the popular as well as one of the practical example I'm going to discuss here. Here you can see here a vulnerable code, and here you can see a fixed code. Okay, here in the vulnerable code, let's understand what exactly it's happened. I mean, what exactly is happening here, and how to fix that particular thing. Okay, this particular SQL query selects all the information from the user table where the username column matches whatever the user typed in, like user input. Okay, so for example, a user types something associated with that column, I mean username column, it will checks. Okay, so here with this particular query, what exactly it happens was it built by directly inserting the user's input into the SQL command. Okay, so whatever the user inputs, that will insert into a SQL query directly. Okay, so that means let's say if a malicious person uses this particular one, okay, by particular input, so uh, this particular query will becomes always true. Okay, that means this condition always becomes true. So this could return all the users information exposing a private data, and this exactly is called a SQL injection vulnerability. Okay, now as a fix for this vulnerable code, this particular code will fix this particular SQL injection. Okay, now let us understand what this script does. So this particular code selects a user from the database whose username matches the value of user input. Okay, so here the important thing was how it works. Okay, so earlier it was directly injecting the user input. Here, instead of inserting the user input directly into the SQL string, the SQL query uses a placeholder. Okay, question mark. Okay, so the actual value, whatever the user input, is provided separately in a tuple. Okay, so this was considered as a separate tuple, so the database engine safely inserts the value into the query. Okay, and then this will return like whatever the user exactly inputs. Let's say if user inputs this, then it will matches with the username. If any character like this exists, then it will return. So it won't become a SQL injection. Okay, so because the user input is treated as data, not as a SQL code. Here in first case, here the SQL is treated as a user input as a SQL query. Here it was treated as a data, and this database will search for a username that literally contains whatever the characters user inserts. It will not return into a, I mean it will not going to insert that into a part of a SQL statement. Okay, so that is the thing here. And likewise, like all the whatever the vulnerabilities comes under SAST OWASP top 10, that will be highlighted here. And now let us quickly recap whatever we covered till now, and some key takeaways and best practices. Shift left security we have discussed, where early finding of vulnerabilities and fixing of them in the early stages of the software development lifecycle. That is the one. And automate everything. That means we need to integrate the SAST into a CI/CD pipeline for continuous security scanning. And don't rely on SAST only. Combine the DAST and SCA also for complete testing. And reduce the false positives. That means we need to make sure tune the tools accordingly and create a custom rules for your code base to reduce or eliminate the false positives. And then train the developers. That means we need to train the developers, because the security is everywhere, I mean everyone's responsibility. It is not just the security team's responsibility. So Here the action items you can start today was pick up a free tool like SonarCube or SimCrypt, and you can start scanning a most critical application where it will find the vulnerabilities and review for top 10 findings, and create a remediation plan for that, and try to integrate the SAST scanner into the CI/CD pipeline. Now, of course, this particular SAST has some common challenges and associated solutions also. What exactly the challenges? So, obviously, there might be too many false positives will come into picture and slow down the development and developers resistance. And here are the some associated solutions. We can tune the rules as severity thresholds and use a severity thresholds. So by this we can achieve managing and maintaining a false positives, as well as thresholds like a kind of a quality gateway setup. And we can run the scans in parallel to optimize the configuration and to utilize the time properly, and then provide a training, show the value with the metrics. That means providing a training and to the respective developer teams that will I mean, these are the some associated problems and associated solutions for this. So remember, security is not a kind of future anymore. It is a foundation for everyone. Okay, so start your SAST journey today, and you will be building more secure applications tomorrow. And thank you so much for watching the video, and stay tuned for more videos.